Unlocking the secrets of a long-forgotten era, scientists unveil 815-million-year-old air. In a remarkable achievement, researchers have extracted and studied ancient air trapped within a rock for a staggering 815 million years, offering us an unprecedented glimpse into the Earth's atmospheric conditions from a distant era. This revolutionary study, spearheaded by geochemist Dr. Nigel Blamey alongside a collaborative international team, has devised an innovative technique to analyze gases confined in tiny bubbles inside halite, a mineral that is essentially rock salt. Published in the journal Geology, https://pubs.geoscienceworld.org/geology article/448651 18824 Paradigm Shift in Determining Neoproterozoic. This research not only pushes the envelope of atmospheric science, but also calls into question long-time beliefs about the Earth's air composition during one of its most transformative periods. Unveiling the ancient atmosphere. In 2016, a group of dedicated researchers gathered halite samples from a drill core located in Australia, driven by the hypothesis that these samples contained minuscule gas inclusions. These tiny gas pockets, preserved since the Neoproterozoic era, were previously dismissed as being too small for accurate measurement. However, employing a meticulously crafted methodology, the team placed the halite within a vacuum chamber, gently crushed it, and subsequently released the ancient gases. This released air was then analyzed using quadrupole mass spectrometers, letting scientists take precise measurements of its composition. There was considerable discussion regarding the oxygen levels that existed over 800 million years ago, Dr. Blamey remarked. By employing a direct analysis of the fossil gases encapsulated in the rock, we discovered that the oxygen content was about 50% of the levels we see today. This direct measurement strategy significantly reduces the reliance on indirect models that had historically produced inconsistent estimates. The findings are groundbreaking, since oxygen levels play a crucial role in understanding the development of early life on our planet. A new perspective on oxygen and the emergence of animals. The team's analysis indicated that oxygen levels hovered between 10.3 to 13.4% of the atmosphere during that ancient period, a figure considerably higher than the previously held estimate of around 2% for the late Precambrian. In contrast, today's atmosphere comprises 20.9% oxygen. This suggests that Earth's environment may have been capable of sustaining more complex organisms much earlier than previously thought. For the first time through this study, we have directly measured the oxygen in the air that would have allowed the earliest animals to thrive, expressed Professor John Parnell from the University of Aberdeen's School of Geosciences. We found oxygen levels between 10.3 to 13.4% of the atmosphere, sufficient for animal life to flourish. This is particularly noteworthy because prior estimates were based on indirect modeling methods. Our initial instincts about accessing ancient air were validated, and it's gratifying to see our hypotheses confirmed. Scientific controversies and diverse opinions. Despite the compelling nature of these findings, there exists a division among experts regarding the interpretation of the data. A contrasting team has reevaluated the research and proposed that oxygen levels may have been closer to 6.6%. While this is lower than the findings of Dr. Blamey's team, it still surpasses many conventional models from that time period. This divergence emphasizes the intricate challenges surrounding the study of such ancient environmental systems, wherein chemical interactions over millions of years could subtly skew the gas readings. Critics also express concern that dissolved gases in the halite could potentially affect the measurements, highlighting the need for further refinement of the methodology used. The research team acknowledges these complexities and has already initiated stricter protocols to bolster the accuracy of future analyses. They're optimistic that continued advancements in extraction and analytical techniques will not only clarify existing disputes, but will also expand our understanding of Earth's atmospheric history, stretching back even further than what insights from Antarctic ice cores can provide. What do you think? Do you find it hard to believe that atmospheric conditions were conducive to life as we know it more than 800 million years ago? Could this new information challenge previous scientific doctrines about Earth's biological evolution? Join the conversation and share your thoughts in the comments below.